The washer formula. When the solid has a hollowed out portion, then we can use the washer or ring method. However, I caution you against just memorizing formulas in favor of understanding the process. Let's consider the given curve. Y equals f of x is the upper curve and y equals g of x is the lower curve. We want to rotate those two together about the x-axis. Depicted for you on the right is a solid after the rotation. Notice that the cross section is a circular ring or a washer. Formula for the volume we know is the integral from a to b of a of x dx, where a of x is the area. In this instance, our area will be pi times the outer radius squared minus the inner radius squared. Then we get that the volume, the integral from a to b of pi times, and in brackets, f of x squared minus g of x squared dx. Example, find the volume of the region enclosed by y equals x squared plus 1 and y equals negative x plus 3 revolved around the x-axis. Sketch the graph of the two equations for the region bounded by the graphs. We have y equals x squared plus 1, that's the upward facing parabola, and y equals negative x plus 3, that's the line with the negative slope. We can visually see 2 points of intersection, so we're now going to algebraically solve for the points of intersection. We do that by setting the y's equal to each other. Negative x plus 3 equals x squared plus 1. Continuing to solve, we'll set this equal to 0. So we'll get 0 equals x squared, adding the x to both sides, plus x, subtracting 3 from both sides, minus 2. Now let's factor that, and we'll get x plus 2 in parentheses times x minus 1. Thus, the points of intersection occur when x equals negative 2 and x equals 1. We'll mark the ordered pairs negative 2, 5 and 1, 2 at the points of intersection on the graph. Now, let's rotate the bounded region about the x-axis and sketch some cross-sectional rings. The area of the cross-section is the outer circle minus the inner circle. So let's look at the cross-section of one ring. We have an outer circle, mark the radius, and an inner circle, which we will also mark the radius. The radius of the outer circle is the distance between the line y equals negative x plus 3 and the axis of rotation, which is the x-axis. The radius of the inner circle is the distance between the parabola y equals x squared plus 1 and the axis of rotation, which is the x-axis. We begin with the volume formula. Volume is equal to the integral from a to b of a of x, that's the formula for the area, dx. Let's set it up. We previously found the points of intersection, so we integrate from negative 2 to 1 of the outer circle is pi times the radius of negative x plus 3 squared. Then we subtract minus the inner circle, which is pi times the radius, which is x squared plus 1 squared dx. Let's multiply out the squared binomial terms. The integral becomes the integral from negative 2 to 1. We'll go ahead and factor out the pi from both of the terms. So pi times bracket negative x plus 3 quantity squared is x squared minus 6x plus 9. Then minus x squared plus 1 quantity squared is x to the fourth plus 2x squared plus 1 dx. Combining like terms, our volume integral becomes pi times the integral from -2 to 1 of negative x to the fourth minus x squared minus 6x plus 8 dx. Let's integrate that. We get pi, and then in parentheses, the integral of negative x to the fourth is negative x to the fifth over 5. The integral of negative x squared is negative x cubed over 3. The integral of negative 6x, the integral of x is x squared over 2, and we multiply that with the 6, which will give us 3x squared, plus the integral of 8 is just 8x, and we evaluate that from -2 to 1. That means we put in a 1 every place there is an x in that integral, so we'll have pi bracket and then negative of 1 to the fifth over 5 minus 1 cubed over 3 minus 3 times 1 squared plus 8 times 1. Then we subtract that same integral again, but this time evaluated at -2. So you have minus, and then in parentheses, minus negative 2 to the fifth over 5 minus negative 2 cubed over 3 minus 3 times -2 squared plus 8 times -2. This computes to give us the volume 117 pi divided by 5.